So when you see log or ln with addition and subtraction, you have to use those properties, right? That's what I think you have to do. Just like the one in our notes, you have two options here. One option is you could add that ln of x over, right? The other option is, what does subtraction go back together to as? Division. Both ways work. It's just whichever way makes the most sense to you. If you're going to put it back together as division, you got to, either way, actually, you got to deal with this 1/2. What do we do with that 1/2? It's not -2, right? Like it's a 1/2 power, and what's a 1/2 power the same as? Square root, right? So if you do subtraction goes to division, you would get something like this. If you add that over, I'll just do it both ways. You could add that ln of x over, and you'd get ln of x on this side. So if you didn't want to put subtraction goes together as division, you could just add ln of x to both sides. So you could have this, or you could have this. Either way, what's the next step? Yeah, we got to get rid of the ln before we can square root it. So if we e it now, remember that we're taking all of that to the e raised to that power. So all of this becomes the exponent now. That becomes e to the 0. I feel so silly putting the caret there, but like people struggle knowing that that's the power. So this cancels out, and I'm going to write that as the square root of x plus 3 over x, and what's e to the 0? Over here, if I e both sides, both of those ln's cancel out, and I get the square root of x plus 3 equals x. They don't look exactly the same, but they're almost the same, right? I mean, they're equivalent. Because what could I do to this side to make it like this? Just multiply by x. So you should end up with this at some point. What's not okay is when you see addition and subtraction of logs, is to just make the logs go away and leave it addition, subtraction, right? Addition goes to multiplication, subtraction goes to division, or move them over. Now what would I do to get rid of that 1/2 power, or to get rid of that square root? It's the same thing. Now I could square both sides, and I could say x plus 3 equals x squared. Oh crap, now what do I have to do? Oh yeah, now I have, I'm going to subtract the x and subtract the 3, just because I like to keep my x squared positive. And now I'm going to hope it's factorable. Oh, it's not. In calculus today, Chloe Carter said, I used to be super excited to use the quadratic formula, and now every time I see a problem I have to do it, I just think this sucks. And I thought that was a pretty good statement. Like, now you're like, oh, I don't want to do this. So, -1 plus or minus the square root of 1 minus 4. What's wrong? Thanks. This is positive 1? Yeah. Over 2? Oh, look, it's perfect timing, so stop working. 13 under the square root? Are both of those going to work? Yeah, ln of x, we can't have the ln of a negative number, so 1 minus the square root of 13 is going to be negative, so you got to be really careful.
There's always going to be that situation, like where it's just going to be one of them. One solution.
We don't really say always that often in math class, because there's always an exception, but oftentimes, yes.
Yeah.
But it depends on, it just depends on the problem, because if, I don't know what 1 minus the square root of 13 is. Anybody know what that is? Divided by 2? Whoa, I just did something on my calculator and it said k equals. I've never seen that before in my life.
There's a lot of, like, every problem that I have is, like, there's always one.
Right, a lot of times the negative one doesn't work because you just have an ln of x, which means if you have a negative number, that's thrown out. But if you do this, oh, I just screwed that up. you get, oh wait, maybe it doesn't work. Maybe it doesn't work. No, it doesn't. You get x equals negative 1.302 as the negative answer. Let's pretend this wasn't in the problem. What if the problem was just ln of x plus 3? Would negative 1.302 work in that problem?
Yes.
So I don't want to say always you throw the negative out, because it just depends what's in the problem. If you have just ln of x, or log of x, you can't have any negative, and so that's why you throw the negative out.
So you have to plug that back into the equation.
Yes. And that's why I said we might have to check, but once I saw that x, I knew we had to throw the negative out. All right, so that's why on most of them you're throwing a negative out.
For the way you write the answer, do you just keep it as like that, or do you solve it?
I'm gonna have you do, I say exact and round, right? So I'm guessing the back of the book did decimal. Is that true? So on my test, it's gonna say give both. So if your answer was this, you would need that, and then you would type it in your calculator and give the decimal that goes with it. Because I think it's worthwhile to do both. Divided by 2.3028. If you're going 4 decimals, I think they did 4 decimals. Yes? 38, very similar to this, except for it's logs instead of ln's. As well as 37. So same idea here. Log of x minus 2 plus log of x plus 5 equals 2 log of 3. Except what's different between this one and the one we just did is you can't just move one to the other side and not have to deal with the properties. On this one, you have to deal with the property of knowing that when you have addition of logs, you can put it back together as multiplication. So we could write this as log of x minus 2 times log of x plus 5 equals, and what can I do with this 2 over here?
Put it to the
Oh yeah, I was like, that's not 9, but it is 9. 3 squared is 9. And if you can write 1 log equal to 1 log, what can you do? Yeah, like the logs just go away. If you wanted to show it just like with the last one when we could say we e'd both sides, on this one if you tend both sides, then the log part goes away. But you can just use the property of saying 1 log equal to 1 log. We can just set this equal to this. I'm just going to go ahead and FOIL it out and say x squared plus 5x minus 2x would be plus 3x minus 10 equals 9. Is that true? So minus 19. I don't want to do the quadratic formula anymore. Should be getting pretty good at it if you're not there already. Should just be like almost like addition at this point for you. We do it so many times. Close. 76 plus 9? Is that true? Is that true? I'm guessing the negative doesn't work. What do you think? We can check. Negative 3 minus the square root of 85 divided by 2 was negative 12 something. It's like negative 6 something. Oh yeah, I shouldn't even have to check. If I have a negative number and I'm subtracting 2, it's going to be negative still. So, you have to throw the negative out again. But the square root of 3 plus 80, the square root of 85 divided by 2 would be positive, right? And be really careful. A lot of people make mistakes typing that in their calculator because if you don't say the whole thing and divide it by 2, you get the wrong answer. What I do when I do this on my calculator, I just do negative 3 plus the square root of 85. I hit enter, and then I divide by 2 so I don't have to do parentheses. 3.10 3.97, which means I really should make that 3010. No, 311. Yeah?
Same thing. What number is
I
it?
struggle with my nines.
What?
31097. So if I'm running, oh wait, I'm running to 4 decimals, not 3 decimals. I don't know how to round. 1098.
Kind of tricky.
I always do 3 decimals. In calculus, you have to do 3 decimals. You can write 17 decimals if you want, but they grade the first 3. So that's what I was doing in my head, was 3 decimals, not 4. And in calculus, you can round or truncate, which means like you can write the first 3 and round with our rounding rules, or you can just write the first 3 and cut it off after that, and they count both of them right. Isn't that weird? So like if your answer was, if that was the answer, it would be 2176 or 2177 would both be correct answers, because they say you can round to 3 decimals, where this means you round up, or you can truncate, which just means you just cut it off after 3. You don't care what happens after. Disregard all rounding rules. It's just weird, right? So they always have in the calculus syllabus, not syllabus, in the AP worked out solutions that like 2176 or 2177. Yeah, right. If you need help on the long, complicated ones, like what did I give you, 29 and 31? I'll be glad to look at your work and help you for where you're stuck, but I don't want to just work it out for you because I really want you to work through it. The only difference on the e to the x is you're going to multiply both sides by e to the x. Your u is going to be e to the x instead of 2 to the x. And then when you ln, it works out really nice because you just ln of e cancels out. So if you need help with that, I'll help you. Don't forget that we're having our quiz on Friday, not Thursday, and that there'll be a calculator part and a no calculator part. But I have extra stuff, new stuff for you to do today.
Just a quick question about 62. So you can't have, like, when it's equal, like,
No. Let's look at 62.
I feel like we should really use it.
You got this?
Yeah, that much.
How would you solve that? What do you do to get rid of ln?
Oh.
Yes. This can't be negative. This can't be negative, right? But this is like saying e to the what power equals -1. Or e to the negative 1 power, right? Something like that.